Student, today we are going to do the topic of the chapter solution. The topic is solid solutions. So what are the solid solutions? We have to understand first of all the definition of the solid solutions. So let's see. So solid solution means that in which the two components of the solution are in solid state when both the components solute and solvent, when solute and solvent both are in solid state. At that time this mixture will be a homogeneous mixture, as we know that the solution is one of the homogeneous mixture in which both the solute and solvent particles will be in the uniform nature, and solute and solvent they both are in the solid state. So let's see how many type of the solutions. So if we see that the solid solutions, they are of the two types. So one is the substitutional solid and another one is the interstitial solid solution. Okay, so first of all we will discuss about the substitutional solid. So let's see what are the substitutional solids. So substitutional solids, these are formed when solute, ions, atom or molecules, they take the position of the solid solvent molecules which are present in the lattice sites. So I want to show that if you have one of the solid, so there are lattice sites where the solvent molecules are present. These are solvent molecules. So if you think that if there is no one here, you can say that this one is replaced by the solvent or solute it is replaced by the solute, not with the solvent. So the size of the solvent and solute particles are same because one is taking the position of solvent molecule, one is taking place of the solute. So let's see how it is possible. So see the diagram again so that you can be clarified. So they think that there are 6 solvent molecules and one solvent molecule think that it is replaced by the another one. So we can say that it is replaced by the another one. So if we say that this one is replaced by the another, so what is this? So this is the solute molecule. This is the solute molecule or solute ion, what may be, but the other ones are all solvents. All these are solvent. So one is replaced by the solute. Okay students, so you can see, so we have substitutional solids. The example of the substitutional solids are bronze, metal, steel are examples of the substitutional solids. So you have to consider that solute and solvent particle are of the same size. So solute ions, atoms, molecules take place the position of the solid solvent molecule here. Okay students, so let's see the another category. The another category before watching the another category, see the diagram that these balls are of the solute. These balls are of the solute. These are of the same size. You can see the size of this one and this one, they having the same size. So solute molecules are taking place of the some solvent molecules. So there are, you can see that the place of the solvent molecule are taken by the solute elements or solute particles. So solute particles must be of the same size of the solvent molecule. So let's see the another category. So in the another category, you can see that interstitial solid solutions. So before watching this, I want to show the diagram that if there are the particles of the solvent particles, then there are some spaces. You can see there are some spaces in between. So these spaces are called voids. These spaces are called void or interstitial site. Interstitial sites. So these interstitial sites, so in this category, in the interstitial solid solutions, here molecules are present. You can see that here molecules are present somewhere in between in the voids or interstitial sites. So such are called these are solute molecules. So they are where they are present in the voids. Okay, students. So there are interstitial solid solutions, so which are formed when the solute atoms are placed in the voids of the interstitial sites of the solid. So solute particles must be smaller than the solvent molecules, so as to fit in the voids in between the solvent molecule. So there is no any replacement of the solvent molecule from its lattice sites. Just there is a going of the solute molecule in between the empty spaces or voids or interstitial sites present in the solid. So tungsten carbide is one of the example where you can see that the carbon atoms which are present in the voids, okay, in the tungsten solid. Okay, students, these are the two categories we have discussed. So in the second category, we have discussed that there is a solute. So if we give you the example of the carbide, so you can see the example here. So these white dots are representing the carbon, and bigger ones are representing, and these bigger ones are solvent, and these whites are presence of the smaller, they are of the small size. Okay, students. So you have seen that the two categories of the solid solutions. So let's see diagram of interstitial solid solutions. So you can see that the atoms are present in the voids. These blue atoms, these are smaller ones. They are solute molecules, and the bigger ones are the solvent metal atoms. So these are the interstitial spaces. stitial spaces. So where they are, these are present. Okay students, this is another category. Let's see usefulness of the solid solutions. So where they are used, so whether they are of the interstitial solids or that one is the substitutional solid, they are used to provide the hardness to the material. They are used to provide the hardness to the material. So substances which are hard, they help in the alloy formation. They help in the when two metals, either they are substitutional type or either that one is the interstitial type, so they are help in the formation of the alloy are the good example of the solid solutions. So toughness of the substances is decided which type of metals we are doing the substitutional and which one is doing the in the interstitial. Okay students, so that will help in the decideness of the toughness of the alloy. Okay students, so thank you very much for watching the video.